name anything in this asset list. Killing me.
All right, we are recording. Good morning, Yasner. Yasnafar. I do apologize. All right, well, Jeff, it is 10 o'clock.
Sounds good. We'll give it another minute or two, see if anybody else joins.
Sounds good.
Well, good morning. Is it Yasnafar? Is that how you pronounce it? Can you hear me, Chris?
Yes. And yes, it is. Yasnafar is correct. Thank you, Yasnafar, for confirming that. All right, well, Jeff, let's get started. This is
I'm
Chris
trying to bring up
Gibbs.
the chat window here. Hold on. Ah, there we go.
All right, you need to share
Okay,
your
great.
screen. You ready to share
Yeah,
your
I
screen?
wanted to, yep, I wanted to make sure I could see his questions if they came up.
Sounds good. All right, Ram, that's exactly what we'll do. We refer to you as Ram. All right, well, this is Chris Gibbs, CRO of Veracity. This is our November 24 edition of the Veracity SDN OT Network Controller demo. Today, Jeff Smith will conduct a demonstration of the Veracity tool to show how it answers some of those questions that people have of what's on my OT network, what's communicating on my OT network, how can I control what's communicating on my OT network. And with that, I'll turn it over to Jeff Smith.
All right, sounds good. I think I need to share my video.
I see your presentation, so it is live.
Okay. I was thinking more along me, but we want the presentation before we want me anyway.
Yes.
So, all right, it sounds good. Looking for. Okay, gotcha. Well, that's good. I was a automation and control engineer for about 25 years before I came over to this side of the house, if you will. I always tell people before I took came over to the dark side. Okay. All right. Perfect. So, OTSDN, and I've got some slides. We'll talk a little bit about it, and I'll kind of run through some of the information kind of pertaining more to OT. If you have questions, it's kind of nice when there's only one or two in the meeting because we can be more of a interactive conversation versus me just going through a presentation like I have to do when there's 20 people, or last time when we had, I don't know, 12 or 15, whatever it was. So if you have questions, let's just shoot them out there and we'll kind of cover them. Can you see my screen okay? Ram, are you able to see it? Okay, great. So, there's some fundamental differences in the way OT networks work. Obviously, right? You're an automation controls guy, so was I for a lot of years. Wrote a lot of PLC logic, designed a lot of panels and clickety clack and HMI and things of that nature. So my background was in controls. So, you know, deployed my first Ethernet network for a control system in 2006. So kind of on the bleeding edge of doing that. And there's a lot of challenges we faced when we did that. A lot of unknowns as Ethernet was spanky brand new, at least from the perspective of control systems. So we learned an awful lot. A lot of multicast at the time, right? Lots of stuff was bouncing, tons of multicast around. Unicast really wasn't a thing yet. So when I look at the software-defined networking and what that brings to the plant floor, I did a talk at S4 a couple of years ago about what would I have done differently had I SDN back in 2006 versus what we had at the time. And honestly, there was quite a bit. There's a lot of challenges that the OT space has that enterprise space doesn't have, cloud space doesn't have, SD-WAN doesn't have. Simple things like it's an electrician at 2:00 in the morning who's changing out a failed IO module. Typically in the enterprise space or the cloud space, there's an army of people, or at least a handful of people, and they're usually very well trained in the art of networks and for them to make changes on the fly when they get a priority one ticket is not so big a challenge as it is for the controls engineers and the OT folks, because we've got a lot of other things to do to keep equipment running. We've got robots, we have change touch points on robots. We've got to tune servos and drives, and we've got to understand, proxies and things, all sorts of things. That means we probably don't touch the network until it breaks, which means that there's a long time in between touching something. So it's difficult to keep that all fresh in your mind. Unlike the IT folks who tend to, it's kind of the space they live in and it's what they do. It's all that they do largely. So they get to keep their hands on it. It's very fresh. So, OT SDN kind of levels that playing field and makes it a little bit easier to manage networks. We had a customer comment the other day to his IT guy, "Hey, I don't need you to go in and set up VLANs for me anymore." And that's exactly right. Makes it much more simple, makes it easier to manage. The key is it's just standard Ethernet. I mean, there's nothing different about our OT SDN controller. It's standard 802.3 Ethernet. Anything you run on an Ethernet network today runs on this. The fundamental difference is it's managed centrally versus having a whole bunch of switches out there that you have to go around and touch every switch when you want to make a change. Or if they move equipment around on the plant floor, which happens all the time, you have to go out and manually reconfigure everything. You can create policy in the controller that pretty much allows the controller to adapt to anything that comes along. And you as a user get to decide how much freedom the controller has to make decisions on your behalf. You can make it very, very liberal, so it can do many, many things, anything it wants to, anytime it wants to, based on policy, or you can be very, very specific and it can't make decisions at all. You have to be the one that makes very, very, finite decisions. So that's kind of a nice twist. One of the things that many of our customers trip over is things like spanning trees or Cisco's PVST plus, or ring loop protocols, ring protocols, or, custom, standards by different switch companies. There's just a lot of variability. All of that is kind of taken off the table with software-defined networking on the plant floor. We don't need spanning trees. We don't need PVST. We don't need VLANs. The network is already significantly more segmented than you could ever do with VLANs. It's micro-segmented. Things like, creating a loop, which I've had electricians in the past or even engineering folks on plant floors that, some of my plants would inadvertently create a loop and take the network down. Well, you cannot do that in SDN. The controller will not allow a loop in the network. So there's some inherent easierness about it, inherent ease about using it that isn't there in traditional networking. The mechanism for segmenting the network is called a flow. And I see you typing, so I'm going to wait a second in case you have a question about the last slide. So the network operates completely at layer 2. So I should say that by and large, layer 2, we have some layer 2-ish, 3 functionalities that we have added to the system. Largely, it's layer 2. So you can physically connect the thing in any ring format you want. You can make it a mesh. You could run cables from all over Carnation from one place to the other. And you're still not going to create a loop that's going to bring the network down because the controller is taking care of all broadcast, all multicast. Even ARPs are handled by the controller. So I can literally have two of the same broadcast domain on the same physical network and segment the two so that both broadcast domains have identical IP addressing schemes, but they never see each other, and the broadcast from one side never sees the other side. So hopefully that answered your question. Now, do I suggest that somebody do that? No. As a general rule, that's probably not a wise choice, but you're more than capable of it from a controller perspective. So the way this concept of flows works is, the network is denied by default, so nothing gets on the wire that isn't explicitly approved, or there isn't a flow created for. So let's say, for example, I create a policy or a rule that says, I want Ethernet IP to go from that PLC to that HMI. When that happens, the controller will automatically lay in the rule or the flows in the necessary switches to get the data from point A to point B. It will always pick the fastest path. So it uses an algorithm called Dijkstra. So yeah, it uses an algorithm called Dijkstra and calculates the fastest path. So everything else is denied. So I might be opening up Ethernet IP or SIP, but I have not opened up ping, can't ping it, which is ICMP, can't get to the web page, for example, all of that type of thing. So if, for example, you lose an endpoint, the controller will calculate or knows the next fastest path to get from that PLC to that HMI. So it will reroute all the flows appropriately so that the traffic is not stopped, right? So you don't lose the ability to communicate with that HMI. So it's kind of a handy way. So in this case, I've got a ring. I used to have a mesh where I used to run cables corner to corner in these switches. And nobody really understood what a mesh, how you could use a mesh on the plant floor, because in today's technology, you just don't. You can't put a Profinet mesh out there or an Ethernet IP mesh out there without a few hoops at best. And in the world of SDN, I could run a cable from this lower left switch to this upper right switch in the corner, and it would actually be, it would pick that path as the fastest path. And then it would take one of the other two paths if something happened to that primary path. Another big thing that happens on the plant floor quite a bit is rebalancing of equipment. So if this was a traditional network and I had configurations in each of these switches, and I make a change, then I've got to go make physical changes, walk out to the switches, plug into them and make changes, or access their web page and make changes. In the SDN space with our controller, the controller knows this device can talk to this HMI. So it doesn't matter where it is in the network, it allows it to talk. Again, assuming your policy allows that. So one of the big things I think that's different than, and it's a conceptual issue, conceptual challenge, I think, if you're like me and you've been doing networking for a long time, traditional switching and networking is largely port based. So you're interested in what port something's plugged into, what VLANs are trunked on that port, what is spanning tree enabled on that port. And if I have, a VLAN 401 on port 4 and I move a device to port 6 and there's no VLAN tagged on that port, it can't talk. Which in itself is a challenge on a plant floor to troubleshoot. I've run into that a few times over the years. In the case of SDN, it doesn't matter. It's very device centric. So it's really only interested in what devices are on the network, not so much where they're plugged in. And the policy that you create, unless you specifically get down into zones and physical locations, is all based on device centricity. So I can move that PLC to a different port as long as there's a policy that allows that PLC to talk to something, that conversation will continue. So this is kind of how the traffic works. There's allowed traffic, which means I've seen this traffic before. There's a policy that allows it. So for example, if I've allowed that PLC to talk to that nut runner over Ethernet IP, the controller is really not involved in that communication. It's just like anything would be normally occurring on a plant floor network. I can cycle power to the devices, I can cycle power to the switch, and everything comes back up happy and talking because there's this thing called a flow in the switch, and the flow was put there by the controller that allows these two things to talk. The way that kind of works is when a packet shows up at the switch looks at the packet and says, do I have a flow that satisfies this packet? Meaning that whatever this packet is, I have a flow that references that packet. If the answer is no, then the packet goes off to the controller, and the controller makes a decision, sends back the flows to the switch to either allow the traffic or tells the switch to discard the traffic. And the switch just the packet goes nowhere. It stops on ingress to the switch. So in this instance, since the traffic is already known, there's already a flow, the switch just does its thing and it just switches traffic like any old switch would. If it's allowed traffic, and this is kind of the scenario I talked about a minute ago, if it's allowed traffic but not seen previously, so in the case of Modbus TCP, the first Modbus TCP packet comes in, the switch evaluates this packet and says, do I have a flow that satisfies this packet? If the answer is no, it sends that packet off to the controller. Once the controller gets the packet, it says, do I have a policy or rules that define what to do with this particular type of traffic? And the policy could be, let all things Modbus TCP talk to all things Modbus TCP. Okay. Could be, let all PLCs talk Modbus TCP to nut runners. Could be very specific and say all PLCs in zone 2 can talk to all nut runners in zone 4. Or it might be very specific where this specific PLC can talk to that specific nut runner over Modbus TCP. So as a user, we have the ability to control the level at which we give the freedom to make those types of decisions. And it's going to be based on risk, right? My background was automotive, so as a senior manager for a $8 billion automotive company, I wasn't really too concerned about new Ethernet IP stuff showing up on the network. I wanted to know about it. But if somebody put a new I/O module on the network and it was talking Ethernet IP to my PLC, I don't really care that it's talking Ethernet IP because that's an approved protocol. It's on the right type of network. So I would get a notification that it occurred, that it started talking. But after that, I really didn't need to know anything about it. One of the ladies I've worked with a lot over the years, we're on a board with Argonne National Labs. She represents nuclear power. And, we kind of joke / don't joke, but in automotives, my level of risk or concern was, if something happens to a vehicle and a potential safety concern for the occupants of the vehicle, or just they're really ticked off because their vehicle quit 20 miles from the dealership. That's my level of risk. Her level of risk was a mushroom cloud about 50 miles wide over central Nevada. So we had different tolerance for risk. So whereas I might be a little more lenient and just say all Ethernet IP PLCs and IO modules can talk, she might specifically say this guy can talk to this guy and this guy can talk to that guy. We have a defense partner or defense customer who uses this exclusively in their facilities. And they're somewhere in the middle, right? They build jet engines for the military, so they're very security conscious, but maybe not nuclear facility security conscious. So again, it's all about risk, and the controller gives you the ability to decide what level of risk can I tolerate, um, and explicitly block. So we can write a policy that says explicitly block this type of traffic. So if I have a Rockwell-based system that's largely Ethernet IP, and I don't want to see Profinet on that network because they really don't cohabitate so well, then I can write a flow or a policy in the controller that says don't allow Profinet on my network ever. Right. So what's going to happen is the switch is going to see the packet. It's going to say, well, I have a policy that says don't allow Profinet. It's going to notify the controller, hey, somebody tried to connect to this port with this device to talk to this device on this port. But the traffic was discarded. But it's a policy that won't let it get through. Now, I usually have people ask, occasionally I will have people ask, well, if the system is denied by default, why would I need a policy to explicitly block traffic? And that's a great question. And on the surface, there's no necessarily cybersecurity answer for that or reason for that. It's largely traffic management, because if you look at how I told you a minute ago, if there's no flow in the switch sends the packet to the controller. So if I get something that's pounding on the network and it's sending a packet every 50 seconds, 50 milliseconds trying to talk to a device, and there's no flow in the switch is going to send that packet to the controller, send the packet to the controller. Switch is going to, it's kind of, I kind of liken it to kids that don't know how to take a no. Like, can I have this toy? No. 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 Eventually there's just a lot of noise. And in the case of the network, there's a lot of noise on the network. If we know we don't want to allow Profinet on the network because it's a Ethernet IP based network, and conversely, we wouldn't want Ethernet IP necessarily on a Profinet network, I can write a policy that says no Profinet, right? Block all Profinet traffic. And that means when the traffic hits the switch says, I have a flow that satisfies this, discard the traffic. So it's going to throw the traffic away, right? What that does is make for a significantly quieter network because there's not a lot of extra traffic bouncing around. If you have PCs plugged into switches, and if they're running Windows, Microsoft operating systems are just noisy. They throw out SMB, they throw out DNS, they throw out DHCP, they throw out all sorts of noise on the network. When you plug that PC into my SDN switch or into an SDN switch on our controller, none of that noise gets onto the wire unless you allow it. So it makes for a very quiet network. The only thing that typically is going on, unless there's an anomaly, right, or exception, that's when the controller gets involved. Normally, the only thing that happens is there's a periodic interval where the switch sends statistics back to the controller. So the controller can update the user interface. It can show devices online, offline, things of that nature. That's called a flow statistic. And that's just a periodic message, pretty small, actually, from the switch to the controller. That's, unless there's something unusual going on, that's largely the only amount of traffic that you see on a regular basis. All right. Think of this as having a firewall on every port of every switch. Now, we happen to have the best perimeter firewall in the world in the ICS 360 Defender series. And there are certainly places where it makes sense, but nobody's going to put one on every port of every switch. Part of me would love them to, from the onset of, they get to buy a whole bunch of Defenders. But by the same token, that would be a management headache because they're just not meant for that type of that low level. First of all, if you could get past the cost, but they're just not meant to manage on a per port basis, right? It's a perimeter appliance. It's designed to be set at the perimeter of something, and really putting it in a large scope like this picture, between a lot of somethings in the switches doesn't make any sense. Now, we do have instances where customers will have traditional networks and they put a Defender in between some obsolete or very old equipment just so they can isolate it down to, but it's a different technology. So from the world of SDN, you fundamentally get what you see here with a firewall on every port of every switch without having to have a physical firewall on every port of every switch. We control left to right traffic across the switch with the SDN network. You can't do that in other networking scenarios. Being able to control traffic north-south is possible in other types of solutions, across a single switch, right? Like this device to this device, I have absolute control through my software-defined switch. I don't need extra devices. All right. Okay. So that's kind of the PowerPoint side of this. Do you have any questions so far, Ron?
Hi, Jeff. Thanks for the
Oh,
presentation. Can you
yeah.
hear me?
Yes, I
Yeah,
can.
here's Ram. Great. I have a couple of questions regarding, for example, you were talking about the firewalls. I wanted to know if also DM sets is can we also implement DM sets on them on this protocol?
I didn't get the question. Sorry.
Is it possible that we also implement DMZ on those on this
Oh, a
protocol?
DMZ?
Yeah.
Yes. You can create a
Okay.
DMZ. And typically what a customer will do is they'll have one of our Defender products at the top of the SDN network, and then
Yeah.
below that is the controls network with SDN. I have another customer who creates the DMZ out of purely the SDN network, and then they have normal enterprise network above it and another SDN network below it. So yeah, there's a lot
I
of
see.
options that way.
And how do you manage all of those devices that are connected to this OTSDN network?
So you manage the devices over the with the controller. So there's the SDN controller, and actually I'm gonna bring that up right now. Did I
Do you have
find the right
possibly
button?
a demo of that, maybe?
Yep, that's kind of the plan.
I see.
Yeah. Let me drag something over here. Can you see the screen pop up there?
Yep.
All right. So this is an SDN network in one of our labs. So it's one I use for demos. So it's not huge, but it's got certain stuff in it. It's got a couple of PLCs. I'm actually remotely connected through one of our Defenders into this laptop. So this screen here is actually on this laptop. I don't need that guy. And so, are you familiar with Rockwell Networks and Ethernet IP?
Not really. I'm mostly familiar with TCP IP
Okay.
protocols.
Yeah. So you'll kind of get what I'm talking about. Is so in the world of Rockwell, there's this they use this software called RS Links, and it's how they communicate with their PLCs. And so if you look in this case, if I let me force it to refresh here. If I look when I've forced it to refresh, so it's not actually allowing anything to talk. So I've got this
Yeah.
PLC out here. I've got a PLC down here. This laptop in a normal or traditional network, I'd be able to see all of these devices, but there's no policy in this controller that allows that. Now, one of my guys was just in here monkeying with the controller, so hopefully it all works the way I expect it to. But if, for example, I want this guy to see this guy, and the controller shows me the path. Now, there's a few ways to set up rules and policies, but the quick way is just to hit control traffic. And when I look at this list of options over here, anything that has a take action means we haven't seen the traffic yet. If it has a none, that means we've seen the traffic, it's just not allowed. So I'm going to apply this. When I do that, the controller is going to, I don't even know what this is. Wait. The controller is going to turn on traffic between my laptop that I'm connected to and that PLC. So now I can browse it. I still can't see the other PLCs because I've only allowed traffic to the one PLC here. If I want to come over here and look at this list right here, let me expand this. If I look at this list, if I go to policy management, when I created that, when I selected those two devices and said allow, it actually created this rule for me. Allow SIP on my laptop to this device. Now, one of the guys has a ping rule in here. So if we go back to our topology and we look at let's turn on IP addresses so I can see IP addresses since I don't know what they all are. So that's 201.26. So if I start a command window and I ping 192.168.201. What did I say? 26. And I just do this, it's allowed, right? Because we saw that policy a second ago. If I come in here, I could change it graphically. I can change it through traffic control, or I can just cheat and I can grab this right here and delete the rule. And when I do that, the controller is going to go out and remove any rules relative to that happening. So what I should see now is that my traffic is timing out because I've explicitly said nobody gets to talk to anybody over ping or ICMP when I remove that policy. I can go back to here and I can say this guy can talk to this guy. You can see it's allowing SIP traffic right now. I can control traffic, and if I scroll down, I'm going to see ICMP. I see the traffic on the network. I'm not allowing it. I'm going to allow it. And when I do that and come back over here, we're going to see that that ping is going to reconnect and it's going to start passing traffic. Now, I have other PLCs on the network. So like here's one at 201.27. The rule I had in there a minute ago, which was allow anything to ping anything, means I should have been able to ping 27 also. Since I took that policy out and I have a very specific policy right now, it just says I can only ping .26, so it's not going to work. If we come back and edit my policy, and again, you can do it graphically or I can do it here, I can say allow any to my laptop over ICMP. That's what the rule is going to look like. So now I've allowed any to that laptop. And when I come over here, we should see that 27 now satisfies the rule because it's part of any. Now I could put that in a zone. I could put it in a group called PLCs. And then I can create policies and rules that specifically dictate what can talk to what. So kind of the same way where here I said, allow proto SIP on device L43 PLC. If I come over here and I grab my laptop and I pick this guy, I can see there's no allowed protocols currently other than ICMP. And I could come in here and say, allow SIP. And if I come back over to links, when it gets around to catching up, we can see that I can now browse this PLC and I can talk to it, but I still can't talk to him, right? I haven't allowed that. But again, I can come over here and either create another specific rule or I can delete this one. I'll edit this one and I'm going to allow PLC SIP on any. So now I'm allowing SIP on any devices. And if I come back to here, we're going to see now that Links is catching up and I can see all the PLCs because I'm allowing my laptop to talk to anything. If I had a different laptop on the network, they would not be able to see these PLCs, only me, because the policies I've created in the case of ICM, well, actually on SIP, they would. Anybody could see them on SIP. Only my laptop can ping things because I've specified the laptop. So you can create zones, you can create policies and apply policies to zones. You can manage your switches through here and kind of see what's going on. You get a real-time inventory asset list. And so when they reset this network up this morning, they went in and labeled a few of the things that I would use in the demo. We can get rid of this guy, and this guy for the moment. We'll just hide them. Get rid of the noise. So I get an asset inventory and a list, right? And I can select just different levels for them. The other thing you're going to get in Rockwell PLCs in particular is as the network, it's brand spanking new. They just fired this up, but it's going to go out and interrogate these devices. So before too long, I'm going to see the serial numbers, the firmware revisions, what the device has got on it in terms of those types of details. So I can come in here and manage devices. I can quarantine devices. I could create a zone called quarantine. And when devices, I don't want them on the network, I can do that. If I were to when I get to the point where I know this guy's serial number, I could, and that device moves from port to port. If things like serial numbers, product codes don't match every time it reconnects to the network, it'll automatically quarantine it because something has changed about the device. So for example, I might have this, I might be tracking the serial number, the product code, one or two other pieces of data that we see from the device when it connects. If I see that same device, the MAC address, if I see that same device connect, but any one of those pieces of data is different, then we assume there's an issue and quarantine the device. Because, the product code with a certain MAC address should never change, right? The serial number on a device should never change. So if they do, that typically means there's something adverse going on. Other things you can do in the controller, you can do change sets for policies. So you can say, for example, my controls engineers can create a policy. They want to add this device, that device, and this device, but an administrator has to go in and approve and edit that policy before it's actually put into action. So it makes it nice. You can schedule certain policies and you can do schedules. So you can turn devices on at a certain time. You can turn devices off at a certain time. So there's a lot of functional things you can do. You get some detailed logs and alerts, right? So everything that I'm doing, here's a rule change. Here was a new rule created. Protocol SIP was detected for the first time. And then this device laptop is now communicating with this device laptop or this PLC over SIP. So you really get a good feel for what's on your network, how long it's been on your network, when did we first see a protocol, when did we first see specific devices using that protocol. It gives you a pretty detailed audit trail or audit of what's going on. And we can push this stuff off to syslog servers and do different things with it. There's a great northbound API on the controller, so higher level SIEMs can pull all the data they want from the SDN network. We have a number of customers in the past that have used tools like Nozomi or Clarity, and all they did was use those tools on the traditional network to pull all of this protocol information and all this type of data and send it to a higher level system. With the SDN network, you don't need to do that because the controller already knows all of that, and it knows it in nearly real time. Right? Clarities, Nozomis, Dragos, those are all applications that ride on top of a network. So they add traffic to the network, noise to the network. We know what's on the network in nearly real time, what it's communicating with, and that doesn't add any overhead to the network because it's a part of the network fabric. So it gives you a real picture of your network in nearly real time, which makes it nice. Did you have a question?
I have a question. Yeah. A couple of questions. First,
Sure.
If I heard it right, somewhere in your presentation, you said even if some device tries to have access and it gets blocked, but you can recognize that device or maybe see its IP address or something like that. Did I understood it right?
Yeah, anything that gets plugged into the network will show up in this asset list.
Anything that has access.
Anything that's plugged in. So even if it doesn't have, even if it can't talk to anything, if we've seen it show up, if you plug a laptop into a port, but no policy ever allows that laptop to talk to anything, you'll still see an entry in this list for that laptop. So it doesn't have to have privileges to talk on the network for us to see it plugged into the network.
Okay, that's interesting.
Yeah, if you think about it, whenever you plug a device in, the device, there's a couple of things that happen. We see a link up event on the switch port, and we will see an ARP from whatever device you plug in. So the controller sees the link event, and it also sees the ARP, so that from that ARP, it can log the device as something plugged into the network. Now, we won't know what its name is, but you'll see the IP address and the MAC address show up in this list.
Exactly. Okay. Good.
You said you had a couple questions?
No, you also answered. No, I got the answers. That's fine. Thanks.
Okay. I love it when I answer more than one question at a time.
Thank you very
So,
much.
yeah. So you can use other third-party tools to grab data from the system. You can manage policy switches, zones. So it literally, I tell people it takes me about 15 minutes to show you how to manage your network. And that's completely different than anything anybody's ever used on the plant floor. If if a controls engineer wants to let something new on the network, it's either got a policy that already covers it, depending on how broad the policies are, or they can literally come in here. They'll plug their new widget in. It'll show up. They can click their widget, click where they want it to talk to, and they can say allow it over Ethernet IP, and it's done. Right. So it's very easy to keep the network secure. It's very easy to manage the network. It's not a full-time job. When you're looking at the topology view, this could be, I can have multiple different networks on here because again, the controller doesn't care about IP addresses. So I can have different controllers, different networks, depending on if I'm in band or out of band management for the network. Anything I click on, I get some details on. So for example, I could see that this laptop is plugged into switch B port 8. Now that's creatively named switch B. It could be op10, right? It could be machine 6. And I can also see what the peers are doing and what they're talking. If I pick a switch, I can see where these other switches are plugged into this. So I can tell that switch A is plugged into port 3 and it's a gigabit, negotiated a gigabit connection. I can see that switch C, which is over here, is plugged into port 4 of this switch and it's a gigabit. And these are the connected devices.
Yeah.
I
have a question, Jeff.
Yep.
Can you also manage the bandwidth? I mean, when I see the switch max speed is so, can I limit that?
Not through the controller. The controller doesn't have control over the switch negotiation or auto negotiation. It's allowing, remember, it's device centric. So it's more inclined to control what's on the devices. It's not going to allow me to force a switch to 100 megabit, for example.
But it doesn't it have access to the management port of the switch?
So when you run a switch in SDN mode, it's really just, there's an agent on the switch really that interacts with the controller. And the protocol OpenFlow, which is the protocol used here, does not have low-level enough access to change functionalities about the switch itself. Now, there are some new technologies coming that do, but in that case, I could probably connect to the switch's UI and force a port. But generally, in today's day and age, at least switch to switch, you want the switches talking as fast as possible. The edge devices could be a different matter, right? Edge devices, some of the older edge devices, if it only supports 100 megabit or you only want it to do 100 megabit, then you can contain that device, right? You can set that device to 100 megabit, for example. Okay. But switch to switch is generally as fast as it can go.
Got that. As we are almost at the end of our meeting, I just wanted to, could you please just shortly tell me about the level management and also how about the history, or can we export the history of
yes. Yeah, all the logs and alerts,
exactly.
They get written to journal files, so they're available for days. And then you can use the syslog server on the system to push all of these off to syslogs. So you have an ability to keep that history. Level management is not something that is going to, it's not a feature that's implemented currently. It's kind of an idea we have. And the idea here is to be able to create various levels like a, like a 7-layer model if you wanted to, for example. And then the devices in each level, you decide which levels can talk to each other. So for example, the visualization level and you can talk to the control level. So the control level's got the yellow box. So anything that I check a yellow box on, I'm allowing communications between these levels. You can do the same thing today with our zone management. This is a more visual way to do it. That's kind of the idea.
Okay,
And
because for me, I've seen, for example, with different level management, you have every every one that has access, they have different access level. For example, an operator has just access to monitor the whole system, and maybe some limited control actions. Or on the other hand, maybe the admin has more action, can take
Yeah.
more actions. And
yeah,
for
this
example,
is
the vendor of that equipment has complete access to the equipment. No, those are.
so level management here is not level management from a person's perspective. The controller allows you to create admin levels, power user kind of levels, read only. So you can have somebody who can get in and look, but they can't change. You can have somebody who can get in and make a few changes, but not all the changes. Like, maybe you don't want them to be able to approve change sets. And then you can have an admin level user who can do anything. They can do everything they want. So that gives you that ability from a user's perspective. This level is networking layers, if you will, levels and layers of access. So everything in here, for example, is engineering workstation is part of the visualization layer. SCADA servers. So for example, let's say I decide that smart devices are a part of, they're a part of industrial level. Where did I just put them? Grab this guy here. So maybe I decide, okay, so this all works. This guy can talk to this guy. All right, yellow can talk to both of these. This guy can talk to blue and blue. So these two can talk. They can't talk to this guy. So I can either add this guy, which means everything here can talk to everything here. I probably don't want that. I really just want some stuff in here to talk to stuff in here. So I might just move this guy here. What's cool about that is if I have 1,000 devices that are classified as IoT devices, I've just changed policy on all 1,000 of them to let every PLC or every HMI, for example, get to them. Or I could add another layer in between all of this. I could add a new level and I could call it, the level in between these two levels. And I could put certain devices in that. So it's more of an architectural assignment of devices versus something as, which zones aren't really granular, but gives you the ability to do policies in a little different way and a little more visually. But right now this is in here and it's more or less for me to show and kind of talk to with customers, but it's not something we've finished implementing just yet. All of our level control right now is done via zones because you can fundamentally do the same thing. It's just not graphical like this.
Great. Thank you very much.
Yeah, and I think the last thing I'll show you is, so this is the current user interface. We're in the process of releasing a newer one. Should be available soon. And it's largely the same, but a little different. Let me refresh it since I think I started this thing up earlier. Yeah, it's a little busier network now. And I can tell it to regenerate if I don't like the look of it. That's better. So I went ahead and regenerated the network. So I've got switches with a lot of devices. There's a lot more ability to search and control and do things. Layout management is all different now. Zones is largely the same, but you can do a lot more searching. Switching is nicer. Used to be in the other UI, if you wanted to look at things on a switch, for example. So if I pop back to the old UI for a second, if I come over to a switch and I want to see the flows on a given switch, I select this, then I select flows. And so I can see the flows on the switch. This shows me what's talking to what, where, and over what protocols. This is the low-level stuff that most customers never get into. Problem is, I really want to be able to follow this across all the switches that it is. Well, I can't really do that in here. I got to go back to a switch, pick a different switch, go to a flow. It's kind of, it's less than optimal. With the new UI, I can actually come in here and go to flows. And now I can pick a switch and say, let me see his flows. And I'm going to see all those flows. And I can say, let me see his flows. And it's going to add those to the list. And right now I can, let's see what's in the list that we want to play with. So now I'm seeing all of the different flows. Of course, I picked two that have, there's nothing in here but R because it's just a virtual network I'm running. But I could come over here and say, for example, if there was ICMP, I could say, show me all the ICMP flows between those two switches or on those switches. So it's a lot easier for me to manage and troubleshoot and look for things to try to understand what's going on. This is the assets list. Everything can now be exported. So you can export them to CSV files or Excel files if you want to just dump the assets out quickly. Policies and rules generation is a little cleaner now, a little bit nicer. So if I wanted to add a rule, for example, and get a nice dialogue, I can pick the policy I want it to be a part of, the directive I want, what protocol do I want, and then it builds the rule for me. So it's just a little more refined. That's my build. My version still has that under construction. Configuration stuff has changed around quite a bit. One of the features we have in the controller that I didn't mention is you can actually put a MAC address here. And let's say that's my laptop. And then if I go out and pick some conversations between devices and I mark them as monitor, it's going to PCAP and send all of that traffic to my laptop. So I'll get a copy of all that traffic. So that's like span porting a whole bunch of different switches. Instead of me having to go span port 5 switches and then put the PCAPs all together to try to figure out a conversation, I can go pick that conversation, change it from allow to monitor, for example, and then it's going to send all of that traffic to this MAC address, which if it's my laptop, I can be PCAPing all of that traffic into one PCAP and I can get the entire conversation. So makes it much, much, much easier to troubleshoot communications between devices on the network than having to go out and do individual span ports. All right. Have you got any other questions? What else can I talk to you about?
Thank you, Jeff. No, that was a really nice introduction. I got familiar with your product. It was interesting for me. And yeah.
Okay.
That was
Sounds
nice.
good. Well, I know Chris is on the call, so I'm sure he can follow up and answer any questions you have as far as if you want to take the controller for a test drive, if you want to, do any kind of proof of concept or get it set up in a lab, we can work with you to help you set that stuff up.
Yep, I will also. Chris also wrote me that he can send me over the presentation. I will have a look on that. Thank you very much.
Okay.
Thank you very much for your time.
Sounds good.
Thank you for attending, and look forward to working with you, Ram.
Yep. Okay, so I wish you all a great day.
You too.
You too.
Bye-bye.